Okay, relative to an origin, right, a point A and point B have position vectors. Okay, I realize a lot of people don't know what are position vectors. Okay, what are they coordinates? No. Okay, just to quickly remind you, 2, 1, 2, for example. Okay, let's say in your GH life, right, let's say we talk about the vector. The vector is equals to 1, 2. This means if we use the XY axis, this is like 1 unit, this is a 2, this one is X, this is Y. This is your point, right? I mean, this is like the point 1, 2. But we talk about position vector, is different. Relative to origin, this is the position vector that we are talking about. This is the position vector, the one in gray. This one is your A. So vector is like an arrow, it's not a point. It's not a point. Okay? So that's why I know the current lecture you are a bit lost, so later I'll explain a bit also. Okay? And so it's talking about a position vector. If you have any question, please feel free to ask. Okay, also just stop me. For P equals to -8, we want to find the length of projection and projection vector of OB onto OA. Okay, so easy question. It's something you all have done before. I just want to recap you. Okay, so it looks like this. Okay, if you have a projection of say B onto A, right? What is the projection? It's very important to know who is the one that's lying down. Who's the one? Okay. Who's the one that's lying down? The one below is being projected upon. The one on top is projecting. Okay, so the one that's being projected upon will provide the unit vector. Okay, so here it's like I shine a light. See, yellow color. I shine a light here. Okay, this is the shadow. This is the shadow. Right? This shadow can be a vector. Okay? When it is a vector, we can find the length of the vector. So over here, can anyone tell me the formula quickly? Okay. So very good. A lot of you know. Okay, so it's B dot A hat. Okay? This is a scalar or a vector? Scalar together with this. Alright? This is the vector, projection vector of B onto A. Okay? Can, right? Is it possible to find the length of this vector?
Yeah.
Can. So we can find the length of this. So basically, the length of projection of B onto A. This is nothing but just like that. That's all. Because we're finding the length of this, right? But how do we do? You see, let's say if I rewrite this, right? Okay? Can I say this is the same as this?
Yes.
Yeah, because you know modular AB is the same as like AB, right? Can. So with that, what is this? 1. Rongxian, what is this? 1. Why is it 1? Ethan. Because it's a unit vector. Unit vector is unit length 1. So that's why you see in the notes they don't even put this down. Okay, so it's just B dot A. So it's that's why in the question in your notes you see it's just B dot A hat. Okay, can. Yeah. With that, find the length of projection and projection vector of OB onto OA. So very quickly, OB onto OA. OB onto OA. Right? So OB onto OA. Correct? First one, we find the length of projection. We know that the OB, OA. Right? This is just OB dot product with OA over OA hat. Okay? Can. This is the length. We are looking at question 1 part A. This is the length of projection. Right? How to find this? OB is just, can anyone read off OB to me? Kaipin, help me read off OB. Negative. Okay, because P, okay. What is OA? OA is 212. So it's like 212, then divided by modulus 2 square plus 1 square plus 2 square. Correct? What is 2 square plus 1 square plus 2 square? Square root? Square root 9, right? This is just square root 9, right? So you cancel off, just put 1 over 3 outside. Okay, right? Can huh? Then after that, dot product, you find 3 plus 2, 3 times 2, negative 2, 1, negative 2, 8. You share 1/3 of negative 12. Okay? Ignatius, are you with me?
Yes.
Okay, last time talk to Basan, now talk to family. Wow. What do you put it beside me? Then you talk to me. Okay. Yeah. So this is just a 4. Okay? Mingalaba can get? Can get, huh? Okay. Cannot get, this is recorded, so go back and can look through again. Okay. Okay, question, after that, find the projection vector of OB on the OA. Okay, that's easy. Right, OB on the OA, you just, again, it's just OB dot product onto unit vector of OA. Right? Over. Okay, then after that, with OA. Right? Oh. Okay, because the formula in your notes was like this, right? B dot A hat dot A hat. This one is your A hat. Okay? This one is the A hat. This one is the B.
Is it correct to write OA and join in order to help?
OA. No, because hat usually we use for free vectors. We use for direction vector. We don't use for position vector. Which one? If you want, you can do this at the start. You can say let the vector, direction vector of OB be B. Yeah. There are only two vectors you know. One is direction, one is position. Position is reference to origin. So I say position, my position all reference to the origin. Direction, it can be anywhere in space. If you don't write that, depend, might be a P. Might be a P. Even though it's very instinctive, like every time you see question, they say OB, right? They say let B. In the question now they write let B is da 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 da. But you cannot say OB then sure you write B. You cannot assume this. You cannot assume this. Cannot assume this. Because B can be a lot of things. B can be a lot of things. Example, if I give you a parallelogram, okay, like O, B, A, C, like that. This can be B. This can be B. Because they are parallel. How they are parallel. Okay, can So OB, position vector. OA, position vector. OC, position vector. But what is B? B is a direction vector. Okay. Okay, so after that, going back to this, very quickly, okay, OB, we are still at part A, OA over model. Just ask question, Any question you ask now, you'll be online forever, okay? Yeah, so you're recording. Then, what's OB dot OA? This portion, right? This portion, Go. This portion, okay, we have actually found it just now. We saw, right, it's actually here. Right, it's this part. Okay, so over here, let's just write it down. This is just negative 4. Alright, the red portion here, this is 1/3 of 212. Right? So answer is just negative 4 over 3, 212. If you want, you can also write it this way, negative 8 over 3, negative 4 over 3, negative 8 over 3. This is fine now. This is fine. Can? Because here there's no more. Previous one, because you're actually finding a length. So you know the difference, right? You see this one? There's a mod of negative 12. Mod of this we want the magnitude of it. What magnitude? Because the vector can be this way, right? It can be A, it can be negative A, but modulus means you always take the positive. Okay, very good question. I was hoping someone will ask that. Okay, it's a very good question. Okay, the more you all ask, the better it is. Now we are a very cozy group. Some has left us, so it means our tutorial can be very comfortable. We can really trash out a lot of things. Okay, 2 tutorials a week not enough. You tell me we do 3 tutorials. Okay, as long as we got time to go through. Okay. Answer is now B. Okay, now let's go to the question again. Okay. For P equals to negative 4, calculate the shortest distance from B to the line passing through O and A. Okay. So what do we do? Find the OB This is A. Alright, we want to find the shortest distance passing through O and A. This is the shortest distance. Alright, again, trigonometry you should know. Okay, if I. Yeah. Then from here, how do we find this? Still remember this is, let's say in the past, if this is B, this is A, right? What is this portion? The green portion is just B times A hat. Okay. So similarly here, this vector here, right? We're just going to take OB times OA hat. But we cannot write OA hat. This is not presentable. So let's write it this way. Alright. What are we finding? Vector or length? So what should I do to these children? Mod. I should mod it. Okay. This is question 1B. Alright. Shortest distance. So I present the shortest distance from B, okay, to OA. Right, and from here, okay, a lot of people will do this. Okay, so OB, okay, this is OB is equals to what? OB is equals to 3, negative 2, 4. Alright. Scalar product, 1 over square root. Oh, sorry. Thank you. 2, 1. 老师老了看不到。好。Okay. From here, what do I do? Can I write this? Can I write 2 over 3, 1 over 3, 2 over 3, and then I do scalar product? Any lazy way? Take out 1/3. Okay, so a lot of students that have gone through, they don't know that you can take out 1/3. They don't know you can take out this. Alright, from here, I just want to tell you something. Revise with you component A times lambda B. A times lambda B. Okay? This is the same as lambda A times B. A vector product. You can do that. Okay, all these associative distributive law will save you. Okay? It was covered in the lecture, but it's covered through true false question. So not easy. The comprehensive notes really cover this in detail. Okay, this one is very important. Okay, we didn't talk about this. Yeah.
Is it the same as lambda A times?
Yes. So A times lambda, this is the same as lambda A. Okay. Then here, basically you take out 1/3. Right? You have 3, negative 2, negative 4. 2, 1, 2. Okay? Solving this, you should be able to get you should get this 7 over 3, 0, negative 2, 1. Okay? Some of you will get something like this. You'll get 1/3, 0, negative 14, 7. Correct? No, it's correct. If you do this, right, you can just take out a scalar. Right? You think about it, you can just think about a scalar. I can do that, So it's the human by nature, we like to see small numbers more than big numbers. We like to see positive numbers more than negative numbers. Positive numbers, I know, won't make mistake. Big numbers, I know, I can better calculate. So like that is the answer. Okay, then with that, this magnitude of this 7 over 3 multiplied by square root 0 square, negative 2 square, 1 square. This is square root 5, you have 7 square root 5 over 3. What's the distance? Okay, distance, so we put units. Okay, so to answer what we asked just now, we put units. So that's the distance. So distance. Okay? Family okay? Okay, what's your okay. Rongxue okay? Okay, 1C. Find the value of P for which OA and OB are perpendicular. Now this is just easy, right? Perpendicular. Okay, all these are very standard questions. Ask you perpendicular, ask you shorter distance. Okay, A levels, you look past 10 years, always come out, every year come out. Don't know, go and hit yourself. These are very standard. These are very direct questions. They are not hard. You just need to know the property you can apply directly. Okay? OA and OB perpendicular. Okay, perpendicular, what does it mean to you? Can I ask Praveen? Still together or not? Together. Okay, ask Praveen. No, double check. Because got some, last time the class I asked, they say, Mr. Tan, not together, stop joking or that. I ask. Oh, still together, not together. Huh? Yeah, correct. All ship still the same, right? Anthony still there. Huh? Who's Sultan? Sultan who? Oh, okay. Okay. Okay, next. Okay, so question, what does it mean by perpendicular? Two vector perpendicular means what? Means something is zero. Can you tell me what is a zero? Dot product or scalar product. I say again, two vectors A and B are perpendicular. This means A scalar product with B is equal to 0 or dot product. Why is this called scalar product? Because it gives you a scalar. Okay, A and B are parallel. Means what? A cross B equals to 0. Okay, does it mean that B cross A also 0? If A is parallel to B, is B parallel to A? Okay. But okay, in general, if A and B are not 0, A, this is equals to like negative. Okay, this equals. Family okay? Oh, face right? Okay, like Miss Ng, right? I can see the 3 lines on the head. Here. Miss Ng, my son, Miss Ng, the face like the third sergeant when she's angry. Check out face. Hey, recording, oh no! Okay. Okay, so listen, okay, so this the, okay, after that, very easy, okay, this just means that, okay, you want OA perpendicular to OB, right? This just means that OA scalar product of OB equals to 0. All these are said by Ricardo. Okay, so this must means that 2, 1, 2 scalar product of 3 negative 2p equals to 0. Easy, right? Scalar product 2 times 3, 1 times negative 2, 2p. 2 times 3, 6. 1 times negative 2 minus 2, 2 times 2p equal to 0. 2p equals to negative 4, p equal to negative 2. Answer come out already. Okay? Can This is for 1C. Cut some part. I lazy this one I go back, I can upload straight away. I can upload right 1 hour after the Okay.
15 minutes.
Okay, then after that, so that's for 1. What's the answer? 1 negative 2. Next question. P equals to 6. Find angle AOB correct to the nearest degree. So we must remember finding angle, that's also an important part. AOB, right? AOB. Alright? What we can do is we must remember finding angle, it must be tail to tail or head to head. Alright, we cannot do this, we cannot take this and find angle. Wrong. Alright? We cannot, so it has to be either tail to tail, buttock to buttock, or head to head. But you have to face each other or face away. Okay? This is the angle. Okay? Can Then with that, this is our theta. OA, you can do this now. AOB, right? AOB. Correct. So I do, you can take OA and OB. OA, OB, easy. So you take cosine AOB. This is just OA dot with OB, right? Over magnitude of OA, magnitude of OB. Angle. Cannot. Sorry. Write too fast. This one is easy, right? So all need to OA is what? What is OA? OA is 2, 1, 2. What is OB? OB is 3, negative 2. P is 6, right? So easy. All the A come out you can do. It's just very straightforward. So 2, 1, 2. Can be hard, can be easy, OA, we know this is a 2 square, 1 square, 2 square. OB, 3 square, negative 2, 6 square. Alright? With that, you should have all 16 over 21. Okay? Then easy. Cosine AOB is you can do a corrections. If I go too fast, you tell me. 21. Then AOB is just equals to. Alright? And answer will come out. So they ask for the answer to the nearest degree. So approximately, this is 40. Okay? Hey. Okay. Okay, can Is who don't know how to do part E? Can I just check? Huh? Benjamin don't know. Okay, can. Listen to me. Okay. Listen to me. Okay. Part E is easy. Part E is just a ratio theorem. Why? Because, like I say, you see a ratio, you see some fraction. Usually it suggests ratio theorem. Huh? Okay, very good. Where P equals to 5, find the position vector of point M on the line segment AB, AM to AB equals to 1 is to 2. Alright, so I tell you, actually a lot of vectors question, it will be very helpful if you draw. If you draw out, it's actually very helpful for you. You can see things much better. AB, right? So you draw AB. M lies on AB. M lies on AB, right? What is AM? AM, AB is 1 is to 2. Sorry, AM and MB is 1 is to 2. So I should erase it. Okay. AM 1. This one 2. Okay. All I need to do from here. This is what I always do. Until now, I still cannot visualize ratio theorem, but it's okay. Life still can go on. Okay. OA, OB. I just write it down. What's OB? OB 3 negative 2 5. I always do this. Ratio theorem, I always do this without fail. Sincerely and honestly, 2 1 2. Okay. After that, crisscross. Or crisscross ratio theorem. Crisscross. 2 go with 2 1 2. 1 goes with 3 negative 2 5. Over 2 plus 1. This is your OM. Okay. Answer come out already. So all goes well should be. Sorry, give me a while. Yeah.
They give us this kind of question, at the position, we need to be able to visualize where are the individual points. Let's say you want to draw a
You don't have to purposely plot like where you draw a Cartesian because that's 3D. You don't have to. Yes, anyhow put also can. Yeah, because it's not specific. I cannot say you are wrong. You plot this way where the line is supposed to look like that. I cannot say you are wrong because I can look from another angle. I cannot say you are wrong. I cannot say you are wrong. It's all about perception. Okay? So it's really yes. You take out 1/3. This is also an acceptable answer. Yeah, so all are fine. This is fine. This is fine. Okay? So this is question 1. Then I'll go to question 2. Question 2, actually we did it on Tuesday, right? We did something similar. We have vectors A. This equals to A is equals to 2P. All these are numbers, and 3P, right? B is equals to 1, 1, negative 2. Anyone don't know how to do part A? Okay, answer. This one is equals to 1/7. Can How about A dot B? Anyone don't know how to do part B? Don't know how to do. Okay, very good. So again, this kind of question sometimes you see first time you feel a bit like frightening, but actually geometrical interpretation in this stage is only like either it's the vector of projection or the length of projection, all those stuff. The last stage. Yes, correct. What is A dot B? What's the okay? The key thing is here, children. The key thing is here. A is a unit vector. A is a unit vector. Okay? So let me ask you, right? This is B. This is A. Right? How do we find this portion? How do we find this? Can anyone quickly tell Miguelaba, tell me what's the gray vector? What is the name? How do you describe the gray vector? I draw arrow. I didn't draw arrow. Describe the gray arrow. Describe this one. How do you of some length? I want a vector of projection of B onto A. Okay, so this is B dot A hat. A hat, right? But if A is already a unit vector, can I say that A is equals to A hat? That means I can say that this is just a A. 丢掉啦, to throw away. This is already the answer, right? Okay? Yeah, correct. This is the projection. Then what is the length of projection? Length of projection is B dot A hat, right? Correct? But if A is already a unit vector, what is the length of projection? It's just B dot A. Oh? That's why they tell you in the question A is a unit vector. So in the exam paper, listen okay, very quickly, you know B dot A, right? One more time, 50 push-up. This means that this is also equals to B dot A hat. Right? So this is just the length. What is this? In your notes you will know this is the length of projection of B onto A. Very good. This is the geometric. And it is in your notes, so you cannot say you don't know. You cannot say you don't know. Sorry? You need to resolve. No, this don't need to resolve. If it's in your notes, you have seen it before.
Why some geometry interpretation is this kind of words on then for one is the data product A and B.
Those is they ask you to solve in terms of A and B. Sometimes.
A dot B, right? The geometrical interpretation is like some formula.
You show me that I can. Okay, so okay. So thank you. So you draw it's fine. You need no. You need to give a geometrical limit. You must draw. We don't just draw. Must write. Or definition, not interpretation. Interpret is your understanding. Next one, give a geometrical interpretation. What do you understand of it? What is vector product A and B? Anyone can tell me? Okay, very good. Perpendicular. Any more? Some I heard parallel something. Vector component. That's the one you're saying. Any more? There are two answers. Very good. Area of parallelogram. Okay, so you think about it. A, B. Don't know? Go and revise. Area of parallelogram is inside. Okay, so this is just if you have A, B. This is just the area of a parallelogram. It's the area of parallelogram. Okay, so you know this one. You must know this. Okay, it's here. This one. If I give you this, this one is the area of parallelogram. Okay, ma? What about area of triangle? Let's say if I want to find this, I want to find the green color portion. A dot B, half A, cross B. This one is the area of a triangle. The one in green. Okay? Can children? I don't call it times. We call it vector cross product. Vector cross product. Can. Right. So I'm going to write it nicely. Okay, so A. Okay, we can say this is the length of the vector component. The vector component of B that's perpendicular to A. Please memorize this. Okay, you have to be able to state it properly. Alright, don't just say, there's something the perpendicular to something. Cannot. The vector component of B perpendicular to A. This is B, this is A. This is B, this is A. Alright, usually this portion here, this length, right? What do we call it? B times A hat, right? Correct? B times A hat. We are finding the length, we take the mod of this. In our question here, A is equals to A hat. right? That's why here this is the same as B times A. Oh, sorry, B not B times B vector product A. Okay, because in this question, A is equals to A hat. Only for this question. Alright. If you don't know this, again go and look at your correct. That means it doesn't work out. Can so this is one definition. Second definition, you can say it is the area of a parallelogram. Okay, whose adjacent sides are A and B. Okay. Okay, can Please, you should know this, you should know this. Okay, next one. Question 3. Relative to an origin, the position vectors of the points A, B, and P are -1, -3, 2, 5, 0, 2. This is 5, 0, 2. And P 1 plus 2 lambda, lambda minus 2, and 2. Right? A is equals to -1, -3, 2. I like to write in this manner. Why? Because usually a lot of our formulas uses it in this form. So I take it this way. Show that A, B, and P are collinear. Okay, anyone can describe what method you use? Yeah, ask anyone. Lambda. A, B parallel. Okay, so you can. There are a lot of ways to do it. Okay, one way. You want to show that A, B, P are collinear, right? One way is you can do this, right? You can say AB parallel to BP, alright? But on top of that, you need to add, just need to add that B is a common point. Okay, so because parallel, it means that there can be two lines like that, but you must show that they meet. Okay. Another way is you can do this, you can just say AB parallel to A, also can. Don't say that. You need to show that it's a scalar multiple. AB is a scalar multiple of A. This is how you show the parallel. Okay. Correct. K A B can. Here, this is the first one, right? To show this, right, actually in a way you are saying either AB equals to K of BP or BP equals to K of AB. You can say that. But you need to state B is a common point. Okay? In fact, if you can, you state for both. That's the best. K equals to some. No need. Because naturally you will find K one. Because when you want to show that there are scalar multiples of each other, your K will appear. Okay? Like you need to show that they are scalar multiples. So this one, it will appear. It may not be found. Like this question is in terms of lambda. But it will be found. Okay, let me just show you. Okay, this is my intention. I'm going to show that AB. I'm just going to show that AP is a scalar multiple of AB. That's what I'm going to do. Very quickly. I'm not going to show any common points just like that. Okay, so basically, yeah, that's what I'm going to do. Okay, how do I know I can do this? Because again, I draw it out. I draw out that I know ABP are collinear. Okay, ABP. Why is it ABP? Because question says so. ABP. A first one, second one, third one. First one, second one, third one. Then I follow lot. You tell me that. Okay. With here, this portion, I find AB very quickly. What is AB? AB equals to Rongxuan, tell me AB, how to find AB? Off your brain, you tell me. Try to look at your answer. Oh, is it? Is it you go and die or is it? Okay. You have to be sure. You have to be sure. Okay. Because fundamental. I must know what. Okay. Never mind. I scold you one time. You remember. Okay. Yeah. Okay. OB minus OA. Right. Then from here, how to find? What's OB? 502. What's OA? -1, -3 and 2. Okay, very good. So solving this, you should get 630. Okay. What is AP? AP will be OP minus OA. Okay. Okay. What is OP? Very good. Minus -1, -3, 2. Okay. So this one should give you 2 lambda plus 2, lambda plus 1 and 0. Okay. From there you solve. I mean you can see here, right? It's possible. Okay. You know that, children, you are trying to show a scalar multiple because when you are doing this, you have this in mind. You need to show that these two are scalar multiples. Alright. So go to the side. Get your hands dirty. Get your hands dirty. One is 630, right? The other one is 2 lambda plus 2 lambda plus 1 0. How do you show that these two are scalar multiples? Some people may get stuck here. Okay, some people get stuck here. But how actually this one what can I do with this? Ignatius, what can I do with this? Times 3? What can I do with this to show that they are scalar multiple? Times 3. Times 3 to the right. So, I want to show these two vectors are scalar multiples of each other. This I cannot just times it by 3. Okay. Factorize. You want to factorize? Lambda plus. Okay, so here I can take out lambda plus 1. What do I have here? 210. Very good. What about the right hand side then? Times 3. You like the number 3 a lot. Is it you are 3 wife, 3 husband? Okay, very quickly. This is a vector by itself. We cannot multiply by 3. It's a different vector. Because you must remember, children. This one. Okay, the vector 1, 2, 0 looks like that. The vector 3, 6, 0 can be like this. It's like 3 times of 1, 2, 0. This now. So if this is example, if A equals to 1, 2, 0, 1, 2, 3A is equals to 3, 6, 0, for example. Are they the same vector? No, right? Vectors are equal based on what condition? There are 2. Same direction, same magnitude. Very good. Sorry? You can say that because you don't have 2. You don't have. It doesn't make sense. You have 2 identical position vector. The same. Okay. Okay. So very quickly, 630. This is the same as 3 of 210. Okay. Correct. Very good. If I can make you angry and then you argue back against me, that means I succeed already. Rather than getting you bored, I make you angry and you stop back at me. Okay. Can you see? 100 plus. Oh, sorry. Very good. That's all planned. Can you see you're paying attention much more? 210. Can you see? They are scalar. Okay, so I can say this, right? AP is actually 3 times of 210. Okay? AB is equals to lambda plus 1, 210. So from here, think it through. AP is actually equals to lambda plus 1 over 3 of AB. Right, you can actually get this now. This is what you must show. This is the final step. You show scalar multiple. Okay? Yeah. Sorry? No, not swap. Not swap. Not swap. Okay, okay. Next. Okay, sorry. Yeah, okay, next one. 3 part 2. Is it very hard? It's hard. Okay. -109. Okay, good. Find the value of lambda such that P is on the line BA produced and the area of triangle OAP is 162 square root 5. Okay? Area of triangle OAP. OAP. Very quickly I can just take two vectors. Tail pointing to each other. Okay? For your info actually, for area of triangle, area parallelogram, it doesn't matter, right? It doesn't have to be tail and tail. If you head and tail, actually still can. Yeah, it goes magnitude. Because we're taking magnitude. Can Ricardo, what did I say? So what doesn't matter? Can head to tail or tail to head, right? Okay, very good. Are you okay? Yeah, stay up strong. Wow. When you have your girlfriend, you like that. When you have me, you like that. 生龙活虎Okay. 生龙活虎 is what? Very energetic, very lively. Okay. So pay attention. When you look at me, you must imagine it's your girlfriend talking. Okay. Next. So this is the same. How to find the area of this? Very quickly. Let me ask Kabin how to find area of OAP. Half? Mod? AO and AP. Also can. So what Kabin is suggesting is this. Take AO times AP. Not A. Why? Never mind. He use his own working, maybe he do. Correct. So from there, we just find AO AP lor. What is AO? 1, 3, negative 2. What is AP? Okay, what can I do from now? Do I continue? Shall I do this? Can I do this? 6 lambda plus 6 over 3. 3 lambda plus 3 over 3. 0. Then I vector product. 1, 3, negative 2. Do I do this? How can I do this? The family can do this? Can I go on? I go on. What is so irritating about my working? Take out, Very good. I like it that you all correct me. Okay. So take out the lambda plus 1. Then 3 and 2, I get 6. Okay? Wow, very good. You all saw the 3 here, right? You saw the 3 here. So I take out 3, 2, 1, 0. Smaller the number, the more you're happy. This 3 also I can take out, right? I take out the 3, cancel this one, become 2. So I have lambda plus 1 over 2. Vector product. Okay, then this should give you 1, 3, negative 2. Vector product 2, 1, 0. Answer come out lambda plus 1 over 2. Answer should be square root. So this should be square root 45. Eventually you have this vector. Right? It's lambda plus 1 over 2 square root 45. Unit square. Nigalaba can do this one? Okay, good. Never mind. This video can. There's a tidbit video, there's a shorter video just on question 4. So you can, question 3, sorry. So next, you know, come again? There's a video just on, what one? You know from the question, alright, what is this equals to? This is equals to what? This is equals to 162 square root 5, right? Correct? So what can I do with the 2? I get rid of the 2. This one times 2 becomes 324. Right? Can I get rid of square root 45? I bring square root 45 here. Also okay, right? Legit, right? Everything is nice, right? Square root 45, I can put it square root 5. Square root 5 times square root 9. Square root 9 is just 3, 324 square root 5. Square root 5 cancel all. 324 divided by 3. Very good. So lambda plus 1. Yes. Later I tell you. So from here, right, based on what you've done, right, you all will have solved for 2 values. So you have so inequality you must know. Modulus. So this means you have lambda plus 1. You keep quiet. Or I'm recording this. I'm sure your parents know. They'll know you're talking in class. Okay, very good. Come again. The mod came from here. The mod came from here. Sorry, maybe I never put. Because here is mod. So here, right, you know, if I take this out, right, module A times, very good, very good. Okay, you ask, how. Sometimes I make mistake, so. Yeah. Because this has to be positive, right? So this also has to be positive, right? So we have to mod the lambda. Very good, very good. I missed this out. You have to mod, you have to mod. Okay? You pull this out, sorry, I should do this. Okay? I should do this. Half already, half. So I mean I should do this first, half. Why is it must mod? Did anyone ask? Because here we are finding we are doing this. So example A. Okay, if we take this out, is this way. Because like you said, got lambda. Lambda is unknown. So that's why you need to mod to make sure it is positive. Let's say if it just okay. Let's say if it's just negative 3, for example. Example like this. Then if I take it out, it has to be more. But let's say if it's positive 3. Let's say maybe 3. If I take it out, I just put 3. Because it's already positive. Good question. Question. Huh? Can. Up to you. But here I'm using negative. I'm showing a negative example. Here I show positive. Okay. Right. B, A. Your P is here. Right. What does it mean? If you look at AP and you look at AB, P is on where BA produce. BA produce. Yeah, P is on BA produce. P is on BA produce. BA 再出去，再生一个孩子就给 P。OK， 好了。Next time to me. Hey, don't talk rubbish. You are under record. I'm going to show your parents. PTN, I have a lot of things to show your parents. I will find the parts where you talk rubbish and I show. Okay, so here, over here, can you see? How are these two related? Are they the same direction? No. They are different direction, right? So, but they are also scalar multiple of each other, right? What do you understand about this K? It's negative. Why negative? K negative because AP and AB different opposite direction. All these are from your understanding. You need to draw. You don't draw, answer will come out. A lot of students don't do vectors because they don't like to draw. When you draw, answers will come out very nice. Ratio theorem, you draw. Find vector projection, you draw. Find length of projection, you also draw. Once you draw, your notes, the scenario will come back to you, then you can solve it. Okay. Therefore, our answer we have 2, right? 107, lambda 107, lambda is negative 109. We will take the negative one. Okay, we will take a negative one. Where did the AB? AO and AB. From the question, right, you know that what you know from earlier, you saw earlier, from this portion, right, you have seen that AB times, you have seen that lambda plus 1 over 3 AP is equal to lambda 1 over 3 AB. This is from just now. Then this and this, right, are opposite direction. What does it mean? It means that this one has to be less than 0. Because if two values are pointing opposite, means they are negative. Okay? So this is less than 0. That means lambda must be less than 0. AB parallel to BP. This question, right, actually what they're doing is in part 2, right, they ask you, the hint that they give you, right, is the area of triangle OAT. You do part 1 already, right? it is still possible because even from whatever we have done in part 1, right, you can deduce that you can still deduce this. You can still deduce this. Whatever you do in part 1, you can still deduce this. That AP and AB are in opposite directions. It is possible, because you are actually doing it. How do you know this, Praveen? Is because P is on the line BA produce. P is on the line BA produce. Line BA produce. P is on the line BA produce. This means that, okay, you see, AP is this direction, AB is this direction. Okay, can.